So one of the things you can check quickly is if it's got power to the unit. You'd expect that to be warm, but it's not 100% diagnosis. So I think we might take the cover off and see if we've got some power in there first. That's the cover off. We've got a telemechanique contact for an overloads. It's tricky one-handed. We've got power on that side. We've got power on that side. That's to neutral. I'm testing to neutral. It's 240 volt neutral. Continuity on our neutral on the contactor coil. Wow, we might have depends how this is wired. I usually used to do them, you'll go power from the control circuit. We start here down to the pressure switch and back up to this last, but it might be done. Turn the power off, and we should check it's off as well. Yeah, that's off. So that wire there. Here, yeah, now it starts here and then goes down and back up, so it might be off on the pressure switch. Right, well, we take the cover off here and check the solenoid coil because that's the next favourite thing. Right, that's the cover off. Got two systems side by side. It's the one that's running. Coil's nice and warm. Full side glass. This is the one that's not running. Aha! The coil's warm, so that's working. So we're pretty sure the solenoid's working, so I think we're going to have to put some gauges on there and see what pressures we've got. This is one of those Copeland compressors I was on about the other day. That's the original Rosalot valves. Well, this is the one with studs, and you get these little adapters you have to fit on there. We've got an elbow there, and that elbow on there. As you can see, it gets very tight, getting it to fit where the original pipeline was. I think the battery's going flat in my torch, so it's not, can't see too well. Anyway, got the gauges on. 22 psi on the suction and about 22 psi on the high side, so we've got a catastrophic leak somewhere. So that's a bit of a hole. I'll have a look over this and see what we can find. Let's cut that off. I had another go at it. I was too near the bit where it was raised, but I've cut it and it puts a nick in there, and then you can bend it back and forth, and it snaps off. You've still got a bit of a hole in there. You can clean that out with something if you needed to, but that's plenty big enough just for a pressure switch. Right, we've got the testers on there. I'll test for a bit. It only went down a little tiny bit. We were definitely going down. I've been having a look around the unit, and I leant on something. I think I leant on the pressure switch and it moved, and I could hear a hiss. Anyway, that is where it's coming out of. On the capillary. I think that's they're both warm, but I think that's the high side one. That's a simple fix. I was starting to worry it might have been in the ice bank. We've got a coil that runs probably all 15 feet with a load of. I've known them leak before, so anyway, get these replaced and here we go. Got the high side one done, HP switch. Just doing the submarine one, that's going to go under here and the brazier in. One of the little tricks with these is I can't get far enough away to get in the picture because I'm right up against the machine not behind me. If you put your finger and a thumb in there, pull that along and unroll it. You get quite a nice straight line there. Anyway, that's got to go up and into there. The way to cut these little pillows so you don't pinch them off is with, you've got some wire strippers and you pick a size that only just marks it. Might need a bit more than that. Right, it's got the new capillaries on there. I'm going to put some cable tie, maybe even tape them together so they don't run through again. I just thought I'd check the fusible plug. So I was thinking of taking it out and resealing it just as a matter of course. But look at it, it's pouring out, so get that done. Get some fresh sealant on there. That's pretty much the gap I've got for working. The pipes there. Wash pump down by the side here. Well, not wash pump, ice water pump. Got that plug sealed up. Leak checked. I've got it on back. Around 40 degrees and evaporating about -8. Sorry bars. That's what you'd expect with this sort of system. And you can see it's just starting to make ice on those coils. It starts on the outside and works its way through to the centre and then comes out around that little key trap at the bottom there. Up and out. Done for years, that's very short pipe run. I thought it'd take more gas than that, it takes about 4 kilos. I thought it'd be more like 5 or something, maybe a bit more, but I suppose it's a short pipe run. Basically the way these work is 2 units make 2 ice banks in here, which the ice ensures the water's always around 0 degrees. This pump here pumps the water up through this pipe and it either goes up here to a spray pipe here and another one up here. This is the tank. Here, the milk goes in, so that trickles ice water around the outside. I think it also sprays it up underneath down there, so that cools the stainless down, which cools the milk down. And then this other pipe here, these 2 pipes here go off to a heat exchanger on the wall, like a big plate heat exchanger. and that pre-cools the milk before it gets to the tank. Well, you've got a thermostat behind there for the Hvac. See it? The milk temperature. And then we've got the blue probes for the ice thickness. Pump down, so as soon as it's got ice, someone shuts. So they're quite basic really.